Hello everyone, here it's Yuanhui Zing, and here I'm going to go over the homework 5 question 2. In the question is giving this function of x and y equal to 1 over a times y power of 2 and times y, and the y is larger than or equal to 1, and x is larger than 1 over x but smaller to y. So first we need to get a two function graph in here. This one is for x equal to y, and this part is for x equal to 1 over y. And they cross at point 1. So by obeying the requirement of x and y larger and equal to 1 and x smaller to y and larger than 1 over y, this shadow part showed what they can get. So this part larger than 1 and this part x is smaller than y but larger than 1 over y. And for the second question is asking us to find a so that this function of x and y is a valid joint density function. To getting that, the density function of x1, y, and we distribution it like this. Alpha, it's between x and negative infinity, and between y and negative infinity. We represent that like alpha and beta. So in here, the final function is like when the x is between infinity to 1 and y it's between y to 1 over y. So in the y 1 over a times y power of 2 and x and derivative x derivative y. By getting that, we just tear it apart, like in here. We just getting the inside part like Rnfx, and it's between y and 1 over x and derivative y. We get the inside part first, step by step, and finally we get it like 2 over a times y power of 2 times L and y. It's the y is between infinity to 1, and finally we got 2 over a and L and y, and divided by y power of 2, and that's what we can get for now. And then we let w equal to L and y, and so which is e power of w, and 2 over a, it's integral infinity to 0 for the derivative of EW, which is W over e power of 2w, and we just calculate use the integral rules, and finally we got this one, -2 over a times negative e power of negative w between x between infinity and 0 is equal to 1. Because so what we got is the term together, and negative times negative is positive. What we got is 2 over a is equal to 1, so a is equal to 2. And for question 3, it's asking find and draw the Magnol density function of x and y. First, we list out the integral of x and y, and there are in 3 situations. So for x, there are several situations, not only 3. So for x larger than 0 and smaller than 1, so integral function for x is going to be infinity to 1 over y, 1 over x. It's x between infinity to 1 over x and 1 over 2 times y power of 2 times x, and finally we can get it's like 1 over negative 2 times 1 over x times x. So which one is 1 over 2? So in the situation when x is smaller than infinity but larger than 1, it's the tangent function of x is gonna be y between infinity x between infinity and x, and 1 over 2 times y power of 2 times x. But calculate it out, but solve the integral function, it's like 1 over 2 times x power of 2. So the graph is going to be like this. X, the density function of x is equal to 1 over 2 until 1, and then decrease to infinity. And when the y larger than 1 and smaller than infinity but larger and equal to y, so the density function of y is like integral of x like between positive infinity and negative infinity, and density function of x and y. And finally we can get it's ln y divided by y power of 2. Where is the function going to be like this? It starts at 1 and it's like a curve and come to decrease to infinity, and in the otherwise is equal to 0. And for the first part, it's asking to verify density function of x and density function of y and the value density function. So what we're gonna use the v is to verify them equal to 1, which them equal to 1. When they equal to 1, which means they are valued. Let's see, the integral of the density function of x So x is between to infinity to negative infinity, and plus this two part together, finally to get this one is equal to 1 is equal to 1/2. This one is equal to 1/2, and the plus together is 1, which is value for x, this function of x, and for y it's same, but in here it's gonna be the ln(y) over y power of 2, and since y equal to e power of w, we tear it in two parts. Negative w times e power of negative w, and between positive x to 0 plus integral of w between infinity to 0 and e power of negative w, which is also equal to 1. So during that two parts, this function of x and y are both valued density function. That's it for question number 2.